Hey guys, welcome back to video number 6 in Unit 6. We're going to have a change of pace here. We're going to talk about balancing equations instead of more naming and writing equations. Before we get started with that, you need to learn about these 7 diatomic elements. Now what this means is there's 7 elements that when they're all by themselves, they exist in pairs, okay? So how you can remember these is by remembering the saying, I bring clay for our new house. So this includes all 7 diatomic elements. I for iodine, B, bring for Br, bromine, clay, Cl, chlorine, fluorine, oxygen, nitrogen, and hydrogen. Another way that I actually remember this by is by remembering this word. This is Brinkelhoff. Okay, so if you remember this one word, Brinkelhoff, you have all 7 diatomic elements here. Bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine. So whenever these are not bonded to something else, they're going to exist like this, H2O2, N2. Now this doesn't mean when I have like H2O, those are not by themselves, okay? They don't need a 2 by this oxygen. It's only when they're all alone when it says hydrogen gas, oxygen gas, and so on. So let's talk a little bit about some rules for balancing chemical equations, why we do it. So first is the law of conservation of mass. Now this says that the total mass of the products has to equal the total mass of the reactants. So if I have A plus B and it makes a new compound C, and let's say I have 5 grams of this and 5 grams of this, according to the law of conservation of mass, 5 plus 5, the total mass of the reactants, or the products, will be 10 grams. Okay? Next we have balancing the equations. We can only adjust the coefficients. We can never touch the subscripts. So if I had H2O in a reaction, I can never change this number or this number right here. I can only put a number in front of it to indicate that I would need more H2Os than just one. And then lastly, the coefficients are placed in front of the compounds, which I just showed you. That's the coefficient. You can never put them anywhere else, never in the middle or afterwards. So let's do some practice here. Example number 1 says I have zinc plus hydrochloric acid producing zinc chloride and hydrogen gas. Okay? So how we do this is we just have to make everything on the left side equal everything on the right side. So if I have 1 zinc over here and 1 zinc over here, it's good. But then I need to move on. I have 1 chlorine over here and 2 chlorines over here. So what I have to do is make the chlorines on the left side equal the right. So I'm going to put a 2 here. That'll make me have 2 HCl's. So I have 2 chlorines now, and I also have 2 hydrogens now. So if I have 2 hydrogens on the left and 2 on the right, then it's equal. Okay? Now, these that are blank really mean there's 1 of those. You do not have to write the 1. You just leave it alone. But if you want to write the 1 right now, you can. So the coefficients are 1, 2, 1, 1 for this first example. Example number 2, I have copper plus silver nitrate making copper 2 nitrate and silver. So let's go ahead and start with this first one. Copper, there's 1 of those, and there's 1 copper over here. Now this is a little bit different. I have NO3 right here. Now remember, NO3 is nitrate. It's a polyatomic ion, meaning it stays together all the time. So if I only have 1 of those over here, and if I look over here, I have NO3 in parentheses, meaning I have 2 NO3s. So if I have 2 NO3s on the right, I need to put a 2 here and make 2 on the left. Now once I do that, I have 2 AGs on this left side now. So I need to put a 2 in front of this AG to make 2 on the right side. So your coefficients in this one become 1, 2, 1, 2. Okay? Next we have aluminum sulfate plus calcium hydroxide making aluminum hydroxide and calcium sulfate. So first, we'll start with aluminum. if I have 2 aluminums over here and I only have 1 over here, if I put a 2 here, that makes my aluminums equal. Next, I have SO4 right here. So I have sulfate, which is a polyatomic ion, and I have 3 of those. So what I need to do is make sure there's 3 on the right side. I have 3 SO4s on the left, but I only have 1 over here. So I need to put a 3 coefficient here to make 3 SO4s. Now let's move on to the next one. We have calcium. There's only 1 of those over here. But since I put this 3 right here on the right side, I need to put a 3 on the left side to make these calciums equal. Next I have OH. OH is hydroxide. It's a polyatomic ion. I have 3 times 2, so I have 6 OHs on the left side. I need to make sure I have the same on the right side. So if I look over here at this OH, there's 3 of them. I multiply that by 2, and I also have 6. So your final coefficients come out to be 1, 3, 2, 3 in example number 3. Lastly, let's move on to this example number 4. So I have 4 aluminums on the left side, and I have 1 on the right side. So what I need to do is put a 4 here to make aluminums equal. Next, I have 3 carbons on this left side, but I only have 1 on this right side. So I need to put a 3 here to make carbons equal. And then lastly, what I need to do is make sure that these O's and H's are equal. So let's move on to O in this water. I have 1 on the left side, but if I look over here, I have 3 OH's. So 3 times 4 gives me 12 O's on this left side. So what I need to do is put a 12 in front of this one to make 12 O's on the left side. And then lastly, I need to make sure that hydrogen is balanced. So I have 12 times 2 is 24 H's. So I need to make sure there's 24 H's on the right side. So 3 times 4 is 12 H's from this methane. And then again, I have 4 times 3, so another 12 H's from this hydroxide. So 12 plus 12 gives me 24 H's on the right side. So now your entire equation is balanced. Your coefficients are 1, 12, 3, and 4. Thanks for watching.